Very good morning to everyone. In this lecture, EC 8351, Electronic Circuit 1, Department of Electronics and Communication Engineering, third semester. Today, we are going to discuss about the BJT amplifier. It is a unit 2. So, the introduction. What is the amplifier? What is a differential type of amplifier? Now we can move to the introduction of the BJT amplifier. The function of differential amplifier is to amplify the difference between the two signals. The need for differential amplifier in many physical measurement arises when response from DC to many megahertz in record. It is also the basic input stage of an integrated amplifier. So we have to discuss the differential amplifier. The two different input, that is a positive and a negative input, or two different value of in the input to differentiate, that is we have to amplify that the single output. Now we can move to the block diagram of the differential amplifier. Say the amplifier stage of two different input, that is a V1 and V2. That is we have to consolidate the difference voltage. We have to amplify that the output voltage is a single output voltage. Now what is the basics of differential amplifier? The output signal in a differential amplifier is proportional to the difference between the two input signals. That is output voltage is alpha into V1 minus V2. Here the V1 and V2 is a two input voltage and the V0 is a single ended output. What is the output? Single ended output. That is a difference gain into the two input supply voltage V1 minus V2. We have to analyze the differential gain of the amplifier. The V0 output voltage is equal to difference gain. That is a differential gain into V1 minus V2. So the AD is the constant of the proportionality. The AD is the gain with which differential amplifier the difference between the two input signal. Hence it is known as a differential gain of the differential amplifier. AD is equivalent to the output voltage divided by differential voltage. So the output voltage is nothing but the V1 and V2. That is a two difference voltage of the input side. So what is another mode? That is a common mode gain. An average of two input signal is called a common mode signal. It is denoted as a common mode voltage. The common mode voltage Vc is equal to V1 plus V2 divided by V2. Here the differential amplifier also produce the output voltage proportional to common mode signal. The output voltage is equal to the common mode gain and common mode voltage, where the common mode is a common mode gain. Therefore there exists some finite output of V1 is equivalent to V2 due to the common mode gain. So the total output of the any differential amplifier can be given as a output voltage is equal to differential mode and differential voltage plus common mode and common voltage. So what are the common mode rejection ratio in the differential amplifier? Now we have to the ratio, that is the ability of the differential amplifier to reject a common mode signal is defined by a ratio. It is called a common mode rejection ratio. It is denoted as a CMRR. So the CMRR is defined as the ratio of differential voltage gain to common mode gain. It is expressed in dB. That is a 20 log in mod of differential gain and common gain into dB. So what are the output voltage? So the output voltage can be exposed in terms of CMRR. That is, we have to see the equation of the output voltage V naught is equal to differential gain into differential voltage plus common gain into common voltage. So we have to simplify that. The output voltage is equal to the differential gain, differential voltage into the 1 plus 1 divided by CMRR into the common voltage and the differential voltage. So these equations we have to explain the CMRR is practically very large. Through the both common voltage and the differential voltage components is present, the output is almost proportional to the differential signal only. So next we are going to discuss the features of differential amplifier. There are the different, so many features are there. First one is a high differential voltage gain. So here the amplifier, so the general amplifier, we have to improve the gain of the amplifier, that is output of the output gain. So here the differential voltage, the two different input voltage or two different value of the voltage is a high gain of the output. It is the first features. The second one is a low common mode gain. It is a common mode gain of the two input voltage. It is a low gain, that is a lower gain. It is a very advantages of the differential amplifier. And then the ratio between the common and the differential mode is high level. There is a high CMRR ratio. Other than two input terminals, we are applying the positive and negative. We are applying the low and high input voltage. That is the two input terminals are there, is available. So the high input gain is achieved. And also large bandwidth. Then the low offset values of voltage and current in the output side, and also the low output impedance are there. So the features of differential amplifier is the main advantages in the analysis of the electronic circuits. In next session we are going to discuss the differential amplifier, how to amplify the two input signal. We get the two different output signal. We have to how to analysis the common mode and the differential mode gain in the identical characteristics. Thank you for watching this video.